Domain and range, we're going to use them in several different ways. We're going to talk about them as x and y values. We're going to talk about them as they pertain to a graph. So the domain of a relation is the set of x values. So it is the x values, or as we learned earlier, the input. Okay, the inputs. It is the set of x values or the inputs. The range of a relation. Okay, put the -2 twice. We've got -4, 1, and -1. Okay, -4, 1, 6, and -1. If you want to put it twice, I'm not going to call it wrong, but remember that your range, again, is your y values, and your domain is your x values. Domain and range is pretty easy, don't you think? Pretty simple. Okay, so let's look at this part. It says sometimes we have points on a graph. To find the domain, we list the x value of each point. And to find the range, we list the y value of each point. When you have something graphed, I'm going to tell you right now, it's much, much easier if you write out what all the ordered pairs are before you try to list the domain and the range. Okay, and I'm just going to make my, whoops, this 5. So I'm just going to write my ordered pairs, and I'm going to start at the very left, at the furthest left point to make it easier. So I've got -3 and 1, 2, 3, 4. So I've got -3 and 4 is my first point. My second point is at -2, 1, 2, 3, 4, 5.
Why is it a positive 4?
It's not. I just didn't put the negative. Thank you for correcting me on that. I appreciate that. Because, you know, I make mistakes. So the next one, I'm going to go to the -2 first, or +1, -2. And then we're at +1, +3. And then we're at +4 and 0. So my domain is going to be -3, -2, 1, and 4. That means those are all the x values that were used. My range is going to go anywhere from -4 to +3. So if I put that in order, I could tell you that my range is going anywhere from -4 to +3 because that's the highest value. So that's why sometimes we want to put those in order numerically. But again, right now, we're not thinking about that as listing. But when we graph, we have to think about it that way. Okay, so does everyone understand the whole ordered pairs part? Yeah? Okay, so let's talk about what happens with a graph. With a graph, you have to look at, the graph, and you have to say, what is my lowest x value and what is my highest y value? So when I look at this, I'm going to say, what is the lowest and highest x value for my domain? Okay, and it says, if there's an arrow, the line is going to infinity. So that's what we've been graphing. I really like the TV. It's nice and bright, isn't it? Does everyone see it well? Yeah, hopefully. If you can't, I can shut the shades, but right now I don't think I need to. So to write the domain, we want to use inequalities because the possible x values are between the endpoints of this shape. We don't just have like two x values, we have a bunch in between. Okay? So this is to get our domain. Our domain in this case, for x values, this is my, I'm going to kind of draw a little box around my shape. Whoops. And I can see for x, I'm at 1, 2, 3. So I'm at negative 3, 1, 2, 3, and I'm at positive 3. Whoops, you guys can't see that. So I'm at negative 3 and at positive 3 on my x values. So when I have a graph, my domain is anywhere from negative 3 to positive 3. And I'm going to put a less than or equal to because it includes those points. And then for my range in this one, I'm going anywhere from here to here. And again, I'm doing that because it's a shape, so it's constrained inside those points. And so my range goes from 1, 2, 3, 4. That's at negative 4. And this is at 1, 2, 3. And this is at y equals 3. And so my range goes anywhere from negative 4 to positive 3. So that's how we write a graph, a domain and a range for a graph. So let's practice on this other one. Same rule here with our y values. We're going from lowest to highest on our y values. And if there's an arrow, it goes to infinity. And so all the y values, again, are between the endpoints. Okay, so if we look at this graph, let's look at this graph, and we're going to say my domain, so my x, here's my x's. If I draw a line right here, this is the value of x equals 0. And this is infinity. So my domain starts at 0. You're always going to put that less than or equal to x, and it goes to infinity. And we do not underline if we talk about infinity because infinity doesn't have an actual value, so we can't underline it. My range in this case, because it's an open-ended value, my range is going to be all real numbers. Usually my domain is all real numbers, but in this case it's stopped at 0. But we can also write it as this, as a negative infinity. And so writing the domain and the range of a graph is hard. I don't ask you to do it very often. I just want to show you, like I said, a couple of the problems. Let me show you one more. Is everyone okay with that? I'll show you two more, and then we're going to just kind of put that aside. We're not doing a lot with domain and range with graphs. But one like this, right here, the x values here are unlimited because there's arrows and it's an absolute value. So the domain is all real numbers. Or we could put negative infinity less than x less than infinity. My range, in this case, goes from here up. So it starts at negative 5, maybe? Looks like a negative 5. It's kind of blurry. So it starts at negative 5, and it goes to infinity. Okay, so from negative 5 up to infinity. Okay. Another one like this one, my domain starts here, but it does not include that value because it's an open circle. And it ends at infinity because there's an arrow. So I would put negative 4 less than x less than infinity. And my range starts at positive 1 and goes up. And so that's my range. So again, we're not spending tons of time on this, so that's all I'm going to do with that. Domain and range, okay? So, but we know domain is the set of x values in a relation. And a set of ordered pairs, I didn't write that down here, a set of ordered pairs is called a relation. When all the x values are different, that's going to be our function. If there's a pattern, okay? But if any of the x values are the same, it is not a function. So domain is the x values, y is the range, and if we have all those ordered pairs, it's a relation, and then sometimes it's also a function.